rubber and heat do not get together. That's, anytime you have a hot application or something that's causing heat, your belt will fail. The number of things that cause the belt to fail, you got a worn groove, worn pulley. If those are worn, you're going to have problems. If you've got shift gauges, that's a way you can check, But I'm also going to teach you how you can get around something like that. If your pulley is worn, everybody's belt manufacturer makes their belts a little bit different. Some can make them a little on the fat side, some can make them more at an angle, and a ship will wear to the shape of that belt. So if you've been using a certain manufacturer and then you change to another manufacturer, all of a sudden maybe that manufacturer is narrower than the one who makes it. The ship wore to the fat guy. All of a sudden you only got contact on the corners. You want whole contact on the sides of those belts. That's what carries the load on there. So the way to get around that, tension your belt. If you tension your belt more, you're going to squeeze it. When you're squeezing, you're going to fill in and be able to get have impact and touch on all sides, both sides of the belt. So you can overcome some worn pulleys. When a pulley gets really worn, you really need to change it. Check it. Use the shift gauge. The belt should never ride in the bottom. If it does, that pulley is worn completely. So always check those. Misalignment. Have a straight edge. You can buy $10,000 laser aligners. They're great. They'll make sure it's aligned perfectly. But really, all you need is a straight edge. Now, you get a really long distance, center distance. You may need a really long straight edge, but a straight edge will make sure that your pulleys are aligned, because if they're misaligned, as they go in and out of the pulley, you're generating heat. Never mix manufacturers on a multi-belt drive. If you get a 3-belt drive, don't put a Gates belt on, a Bestorq belt on, and a Goodyear belt on. Everybody makes their belts different. And even the RMA standard for a B32, RMA says B32 is 32-inch ID. Well, to be the RMA standard for a B32, you can be 0.5 either way and still be a B32. Well, if you've got a guy making it a little on the short side and another guy making his B32 on the long side, you can have an inch difference easily between them.
You mean 0.5 as in half an inch?
As in half an inch. Half an inch. Yeah. So that's why you never want to mix vendors. And even within that, you need to be careful, because somebody like Granger, they do not. Their brand is Dayton. They don't make belts. They go out and job it and have the Dayton label put on it. And every 2 years they go to another factory. So every 2 years, those belts are coming from a different factory. And even though they all say Dayton B32s on them, they could be different belts completely. So you really never want to mix manufacturers, because you could have a problem. If you have different manufacturers on a pulley and a belt fails, one of those 3 fail, I guarantee you the belt that failed is your best belt. And the reason it failed, it was the one doing all the work. It was the one carrying the load. I opened up a unit at USC Medical Center. That belt in the middle was just bouncing away. I'm sure you've seen it, just going like that. Told them you never have to change that belt. Why? Because it's not doing anything. It's just going around for the ride. Simple as that. If it's got a 3-belt pulley on there, it's designed for 3 belts performing equally. If one isn't, the other 2 belts are working too hard. They're going to fail too soon. So never mix vendors on a multi-belt drive. Making sure you have the right belt on the drive. Don't try putting the B section on an A section. Some people will do anything to get a belt up and going. So make sure you're not doing that. That'll cause your belts to fail. Pulley diameter. Using the right belt on the pulley diameter size. I'm going to tell you, this is pretty much industry standard. If your smallest diameter pulley on the drive is smaller than 4.5 inches, you should be using a cog belt. And the reason being is The cogs in the cog belt allow that flexibility to go around that smaller pulley that you don't get in the solid wrap belt. Should always be using that on anything 4.5 inches or below. If the smallest pulley on the drive is 9.5 inches or larger, don't buy a cog belt. The performance between a wrap belt and a cog belt at 9.5 inches and above is exactly the same. So don't spend your money on buying a cog belt when you don't need to. Between 4.5 inches and 9.5 inches, cogs perform better than wrapped, but they perform at the same rate. You know, once below 4.5 inches, all of a sudden cog performs so much better than a wrap belt. You know, so just be aware of that, and just keep that in mind. The smaller the pulley, you're definitely going to want a cog belt on there. It makes a difference on the performance and the life of the belt. Make sure you're not overloading it. You get into some engineering things on there that causes it to heat up. Obviously, the ambient temperature will have an effect on the belt. And here in Las Vegas in the summer, it gets a little warm. And if you've got belts inside a metal box, it gets a little warm inside that box. That'll have an effect on the life of the belt. And then obviously belt quality, whoever makes the belt will have that effect. But I will tell you, 99% of the time, when belt fails due to the heat buildup, it is insufficient tension. We have done this training to about 170 people around the country in the last 3 years, and I'm going to tell you, don't feel bad. Only 5 people have tensioned the belt correctly.
I would have been number 6.
Yeah. So 99% of the time, it's an insufficient tension. Now, if you have a laser thermometer, you've got one of those on you, you can determine if you have a problem with just that. All you have to do, shoot the frame, get the ambient temperature, then shoot the belt coming out of the drive. If that belt is more than 30 degrees above the ambient temperature, you got a problem. Now what that problem is, I don't know. It could be a lot of different things. It could be, misalignment. It could be worn pulleys. It could be, your shaft is bent. Your bearings are going. It could be a lot of different things, but something is causing the heat to build up, and it shouldn't be building up that much. But 99% of the time, it is insufficient tension. Your belt is slipping in that pulley. And when you talked about bearings, how's it, if I put it on this tight, what's the effect of that on the bearings? Okay, we actually did some studies on that if you don't tension your belt, you're going to ruin your bearings. Now, the caveat to that is if you have a large overhang load, the pulley's out here, you got a long shaft before you get to the motor, and you're cranking that thing tight, you're going to have a problem. Now you can be bending the shaft on that. But in most applications where the pulley's right up next to the motor, you can load that belt up really, really hard. Give you an idea, we took the belt, set it on the machine, let it, set it to the RMA standard, exactly to the RMA standards, let it run so it gets seated in there. Then we took a laser thermometer and we shot the bearing temperature. And it's at that chart's actually on that one of the handouts there. Set it at about 124 degrees. That was the bearing temperature there. We doubled the tension on that belt. Let it run, shot the bearing temperature, 124 degrees. We tripled the tension on that belt. That belt felt like this tabletop when you pushed on it. Let it run, 124 degrees. So we took it back down to the RMA standard and then let it slip 5%. That's all. Let it run, shot the bearings. Bearings is now at 181 degrees. And the reason being is you have slippage in that pulley, generating heat in the metal pulley, transferring that to the metal shaft, transferring it to your bearings. So if you want your bearings to last, you want your motors to last, tension your belt. If you're not tensioning your belt, you're burning up your motors. Now, I know that's counter to what we've all thought, and that's why we've done all the testing on it, But we actually had a guy down in Phoenix who had the same, he called and said, your belts are failing, your belts are failing, I'm gonna return them all. And we got this, my boss said, no, I'm coming down there, take a look at it. And went in there, he's got big building, we got 40 units up on that roof. And Dell went up there and these belts were loose as can be. He goes, well, you're not tensioning the belt. And the guy said, no, the way you tension them, you'll burn up my motors. Dell said, nope. And they got into an argument on the roof and said, tell you what, I'll tension those 20, you tension these 20. And the guy says, no, you'll burn up my motors. And Dell said, I will buy you a new motor if I burn up any one of those motors. And he tensioned those 20 units on the roof, the guy tensioned the other of them. 3 months later, had not heard from him. We went back there, went up there and said, any problems? He goes, well, not with the 20 you tensioned. You know, and it's just, if you make sure your belts are tensioned, you're not gonna have a problem because that's what usually causes the heat buildup. So if you want your bearings to last and your motors to last, tension your belt life, you want it to last, tension your belt. Now the other thing you wanna look at is the quality of the belt. One of the things, I guess, to give you an idea,